Okay, let's do a couple more questions. 3.4. An organism is homozygous recessive. So let's use, I don't know, let's use the letter little r. So it's like this, little r, and it's crossed with a heterozygote. So that means the other parent is a big R and a little r. That's what those mean. What is the chance of getting a homozygous recessive phenotype, which means it'll look like this? So what are the chances of that? So just do the cross. I mean, this is like one of the easier questions I've seen. So little r, big R, little r, this first generation or this offspring. Maybe the confusing part is this. That's just like the babies. So 2 heterozygotes for every 2 homozygous recessive. So the correct answer is 50%. The next question. So here's another example of sex linkage. So we talked about colorblindness being sex linked, but so is the disease hemophilia. So hemophilia is another disease you remember. We use the letter H, so females can be, whoops, oh no, what did I do? Females can be homozygous dominant. Females can be a carrier, so that means it's heterozygous, and a female can be affected if it's both little h's. Please remember to have your sex, your x's and your y's there. And then males can only be 2 situations. Males can be healthy, nothing on the Y chromosome, right? Or a male can have hemophilia. So a woman is a carrier. So carrier is another word for heterozygote or heterozygous. So she is this. So let's put her on the box. We'll put her as a big X and a small x. And it's crossed with a man that does not have hemophilia. So he's unaffected. So that would be this gentleman. So he's got a big H and a Y, nothing on the Y because the chromosome is too small. And then you do the cross. So I'm not going to draw the X's because my boxes are too small. Here we have big H, big H. In this situation, we have a big H and a little h. And then for the males, here's a big H and nothing on the Y. In this situation, we have a small h. So if you look at this, only this side is the male, so 50% of the boys will have hemophilia. Did I say color blindness before? 50% of the boys will have hemophilia and 0% of the girls. However, this one is a carrier, but still not affected. So the correct answer here was A. Question number 6, classic blood type question. So with these questions, the best thing to do is to look for evidence of what you know to be 100% true. And the only thing we're sure of, and right from the get-go, is that this person is, the genotype is little I, little I. If you remember blood type, we have different possibilities for all of the different blood types. So if you're blood type A, these are the 2 genotypes you can have. If you're blood type B, you can be this or this. The other blood type is AB. That's an example of codominance, please remember. So that means both of them are expressed. And if you're blood type O, your genotype is little I, little I. So we know that has to be the case. But what about blood group A? Because we're not sure if it's this or if it's heterozygous. However, if we have a child from this father, if we have a child that has an I, it must be heterozygous because one of those went in there to make that child with I. Also, we know in this individual here, one of the alleles has to be an I. So it could either be an IA or an IB. In this situation, it's IB, right? Here, this situation is heterozygous because this I and this I made this child. And the only thing that works for number 2 in this diagram is we have another heterozygous for blood type A, and all of this works out. We can still get blood group A's, we can still get blood group O's, even if this parent is a blood group B, and that's why the best answer was this one.